Hey guys, welcome to another video for Algebra 2. In this video, we're going to be looking at graphing rational functions. Okay, so I want to work out a couple of problems that are going to highlight some of the different scenarios that you'll see in your worksheets and in the book and in quizzes and so on. So the first one I want to look at is x squared plus 5x plus 4 divided by x plus 3. So one of the things that I want to consider that, and there's only a few things that you want to consider, and you want to do as many problems as you can with this so that you can get used to looking at these problems this way. One of the first things to consider is that when I have a fraction, that you never want a 0 in the denominator, right? A 0 in the numerator is okay because that just equals 0, but a 0 in the denominator is not okay because that's undefinable, right? That's breaking math rules there. So one of the things that I want to do then is look at my denominator, and I want to ask myself, what number would make that 0? So it's pretty simple to do. You just kind of zero it out, and x equals -3. So that means you never want x to be -3. Because if x is -3, then that means in this particular function, you're going to have a 0. That means it will not be defined. So essentially what that means, again, this is the first thing you want to look at. What that means is that at -3 in my graph, at -3, that means that I never want it to be -3, and it can't be -3, so that means there's an asymptote at -3. So that means as I draw my function out, in some way I'm going to have to avoid -3. My function is going to have to avoid -3. Okay? Now, the next thing I want to do, the next thing that I want to pay attention to, the next thing I want to look at is I want to look at the degrees of the two functions of the denominator and the numerator. So the numerator has a second degree and the denominator has a first degree. So that means if my numerator is 1 degree higher than my denominator, that means I'm going to have what's called an oblique asymptote. Okay, now to find out what that specific oblique asymptote is, I actually want to work this out. So I'm going to work out the function x squared plus 5x plus 4 divided by x plus 3. Okay, so I want to work that out. And if you remember doing long division with rational functions, this is not really what I want to focus on in this video. So we do want to. We can review that in class a little bit more, so I'm going to kind of go a little fast on that. So what do I need to multiply x by to get x squared? Well, x. So then I use x, I multiply x by x, that's x squared. X times 3 is plus 3x, and remember I want to subtract that whole term. So this ends up simplifying out to 0x, and then 5x minus 3x is 2x. And I want to bring down my 4 plus 4. And so now the next question I want to ask myself is, what do I need to multiply x by to get 2x? Let me get rid of that there to clean it up. So what do I need to multiply x by to get 2x? And that's plus 2. So 2 times x is 2x, and then 2 times 3 is plus 6. And again, I want to subtract this whole thing. So that factors out to nothing, so that cancels that out. And then 4 minus 6 is minus 2. So that means my remainder is minus 2 over x plus 3. So now that I have this worked out, now the one thing that the part of this function, the answer that I want to pay attention to is actually this term. Because remember, right now I'm just looking for my vertical or my oblique asymptote. And that was because my numerator was 1 degree higher than my denominator. So I have x plus 2, so I wanna graph that oblique asymptote. So at 2, right, and then my m is 1 over 1, so it's rise 1, run 1. So that means my oblique asymptote is this line right here. So that means that as I make out my function, my function has to avoid these two asymptote lines. And so now the next goal that I have is to actually figure out how my function is behaving in accordance with this particular equation. So that means what I want to do is I want to look at -3. I want to ask myself, how is this function behaving at as close to -3 as possible? So I want to make a function that has, and I want to see how close, how this function behaves really close to -3. So I'm going to pick negative 3.0001. And the more zeros I add, the closer I get to -3, the better, because that's going to tell me how this function behaves. So when I input negative 3.001 into all of my x's in this function, and you can work that out in your calculator, you're going to see that you're going to get a really high number way up here. And what that's telling you is that this function is essentially going up, and it's following that asymptote all the way up forever and ever, getting closer and closer and closer to the asymptote, but actually never touching. And so that means as it's going up, as I'm going down, that means this function also is going to follow the oblique asymptote, right? It's going to follow that oblique asymptote forever and ever and ever, but never actually touching. And now that I know how it's behaving on the left side, I want to find out how it's behaving on the right side. So I want to pick a number that is really close to -3, but on the right side. So I'll pick something like -2.9999. And again, the more nines I pick, the closer to -3 I'm getting. And when you put that in your calculator, what you're going to find is that you're going to get a really, really low number, which means that this function is actually going down. And again, it's hugging that asymptote, but never actually touching. Okay? It never actually touches. And then as it's going up, as x approaches infinity, this function is now it has to by force, because remember, it cannot touch that asymptote. It can't cross it. It hugs that asymptote, and it gets closer and closer to it as x approaches positive infinity. Okay, and that's essentially what this function is going to look like. Now, I'm not super concerned about you having like a really accurate function drawn. I just kind of want you to get the general idea of what the function and how it's behaving, given the parameters of the equation that you have. All right, so let's look at another one. So let's say we have x squared minus x minus 6 divided by x minus 3, and this is f of x, of course. So again, remember from the previous equation that my numerator is 1 degree higher than my denominator. That means I'm going to have an oblique asymptote, right? You remember that from the previous problem? My degree was 1 higher than the other, so that means I had an oblique asymptote. So I might have something that's going to look like my previous equation. Okay, so I'm writing that down to keep that in mind. So what I'm going to do next, also keep in mind, actually, that my denominator, what number can x not be? Right? It can't be +3, right? X minus 3, it cannot be 0, first of all, so that means x cannot equal 3. So that means at 3 I will have an asymptote. Okay, now this particular equation, you can kind of tell that, I can kind of tell that there's something's going to happen here, something that's another point of importance for you to keep in mind. And I'm going to realize this once I factor the numerator. Watch what happens when I factor the numerator. X minus 3x plus 2. Now, do you notice anything there? Now, what that unveiled, that I have two factors that are actually the same, right? Now, when you have two factors that are the same, one in the numerator and the same in the denominator, you actually cease to have an oblique asymptote. At that point, what you're going to end up with is something called a point discontinuity. Okay? And the point discontinuity is going to stay at 3. Okay? So, my graph, I initially thought that at +3, I was going to have an asymptote. But as it turns out, that's not going to be the case. But something is still going to happen at 3, and it's what's called a point discontinuity. Now, in order to show you what a point discontinuity is, I need to finish this function out. I need to find out what the function is going to look like. So like the previous problem, I'm going to work it out. So I need to have x squared minus x minus 6 divided by x minus 3. So let me work this out real quick. So I have x, that's going to be x squared. X times negative 3 is negative 3x. I subtract this whole term, so this cancels out, and I end up with negative x. Let me use a different color. I have negative x plus 3x. That's going to be 2x. Bring down my negative 6. And now I need to factor this out. So what do I need to multiply x by? That's plus 2. So that gives me a 2x minus 6. And I subtract this whole term, right? 2x, and then 2 times negative 3 gives you minus 6. So that means this factors out, cancels out, and then plus negative 6 plus 6 is also 0. So that's it. This is my function. So I want to graph this. My y-intercept is at 2, and then my slope is 1 over 1. So then it's my graph basically, as I go down, as x approaches negative infinity, that's what it looks like. And as x approaches positive infinity, it's going up. But keep in mind that at 3, I have what's called a point discontinuity. So that means that at 3, this function ceases to exist. It stops. I have a point of discontinuity. I jump, and then I continue, and then it goes on. And that's essentially what my function looks like. So the function is a function until you reach 3. There's a point discontinuity. And again, that's because as I factored my function out, I realized that there were two terms that are the same. And it went from being an oblique asymptote to becoming a point discontinuity. Okay. Do I have time for one more? Let's fit one more in. Okay, I have f of x equals x squared minus 6x plus 8 divided by x squared minus x minus 2. So I think one of the first things I want to do first, this one's a little bit more involved than the previous two, is that I want to first factor these two terms out, the numerator, and I want to factor out the denominator, if in fact they are factorable, and I believe they are. So x minus 4, x minus 2, and I have x minus 2, x plus 1. So as I look at my function there, let me highlight a little bit more. As I look at my function there, I realize that I have the same factors in the numerator as I do in the denominator, right? Now, also, let me rewind a little bit looking at the top one. Notice that my degrees are the same. So that means I do not have an oblique asymptote, right? The numerator has to be one more than the denominator. And since they're the same, there's no oblique asymptotes. But I do have terms that are the same. So that means and the number I don't want this to be is 2, right? Because 2 minus 2 is going to give me 0. And that means 0. Whoops. That means 0 times whatever this is going to be 0, and I don't want that. So, but because this one and this one are the same, I'm not going to have oblique, but I'm going to have point discontinuity. Right? So at 2, I will have a point discontinuity. So as I'm looking at my function, as I'm looking at my graph, the visual representation of what I'm going to do, at positive 2, I will have a point discontinuity. Now at this point, I don't really know what it's going to look like yet, so I'm not drawing anything. I'm just keeping in mind that at 2, there will be a point discontinuity. Now, the other number I need to pay attention to is x plus 1, because that can become a 0 too, right? So at negative 1, at x equals negative 1, at that point, now also in my numerator, I don't have another x plus 1, so that means it stands by itself. So that means that at x negative 1, I will have an asymptote. So two things to consider. Number 1, I will have point discontinuity at positive 2, and at negative 1, I will have an asymptote, and I already have that drawn out. So the next thing I want to do is I want to figure out what the function is going to behave like. So I want to pick a number really close to negative 1 on the left and really close to negative 1 on the right. And again, on the left side, you're going to find, so I'm going to have to find the function of negative, let's say 1.0001, and then I input that into my function. And then I also want another one of, let's say, negative 0.9999. And you're going to find that on the left side, your function is behaving something like this. And on the right side, when you do this function, you're going to have a number really low down here. So that means your function is behaving something like this. But remember, at 2, there's a point discontinuity, and then it continues to move on. Okay? And that's what your function is going to look like. So 2 things to keep in mind: point discontinuity at positive 2 and asymptote at negative 1. And it's important that you go back and review this, watch this video again, really give it a lot of thought. Number 3 is a really good one in particular because you have basically the different scenarios that you're going to come face to face with. You have point discontinuity and you have asymptote. Number 2, you have point discontinuity. Number 1, you have oblique asymptote, and you also have a normal asymptote too. So I hope this helped, guys. Thanks for watching and good luck in your study.